Hey guys, welcome back to my channel. Today we'll be solving questions 19 through 23 of exercise 8b OP Malhotra's textbook for ISC Mathematics. So let's begin. So the 19th question, again based on the chain rule, is cos of sine x square, differentiation of that. So using the chain rule, we keep sine x square as one term, let's say t. So we have differentiation of cos t, d by dx of cos t. So we know that the differentiation of cos is minus sine. So we have minus sine t into the differentiation of t. So basically minus sine x square into the differentiation of, let's keep x square as u, sine u. So minus sine x square into, we know that the differentiation of sine is cos. So into cos u into the differentiation of u. This is the chain rule. So minus sine x square into cos of x square into the differentiation of u is basically the differentiation of x square, which is 2x. So the final answer is 2x minus 2x sine x square cos x square. Okay, so now we have the 20th question, the differentiation of cos x cube, cos square x cube. So if we keep cos x cube as t, we have the differentiation of t square. This is 2t into dt by dx. So 2 cos x cube into the differentiation of cos x cube. So now we will differentiate cos u, where u is equal to x cube. I won't be substituting this from the next question onwards because I think you'll get the idea till then. So we have 2 cos x cube into, since we have cos u, the differentiation of cos is minus sine, so it's minus sine u into du by dx. So that is 2 cos x cube into minus sine x cube into the differentiation of x cube is 3x square. So finally we have 2 into 3 is 6, so 6x square minus sign here, cos x cube sine x cube. We can simplify this. We know that the differentiation of we know that the expansion of sine 2x is 2 sine x cos x. So if we keep 3 minus 3x square outside, we would have 2 cos x cube sine x cube. So that is the expansion of this. So we have minus 3x square sine 2x cube. And one small correction in the previous question. This was sine t, and t here is sine x square. So this would be sine of sine x square. Finally, we have sine of sine x square. Moving on to the 21st question. We have the differentiation of root a plus root a plus x. So again, we keep this as one term. So the differentiation of root t, we have to differentiate it with respect to x as stated in the question. So this is 1 upon 2 root t into the differentiation of t. So 1 upon 2 root a plus x into the differentiation of a plus root a plus x. Now we know that a is a constant, so its differentiation is 0, plus again a plus x is one term, let's say u, so that becomes 1 upon 2 root a plus x into the differentiation of u, which is a plus x. The differentiation of u would be 0 plus 1 because the differentiation of a, which is a constant, is 0 and the differentiation of x is 1. So finally we would have 1 upon 2 root a plus x into 1 upon 2 root a plus x. That gives us 1 upon 4. We can multiply the two roots, that is root of a plus x into a plus root a plus x. but I think that'll make it too complicated. So let's just keep it as 1 upon 4 root a plus x into 1 upon root a plus x. This is the simplest way of keeping the answer. Let's just cancel this out. Next, we have the differentiation of mod of x square minus 7. And as stated on page 811, chapter 811, the differentiation of mod x is x upon mod x. So we have x square minus 7 upon mod x square minus 7, and now we have to differentiate x square minus 7 because this was our first term. So using the chain rule, we differentiated this and stated it in the form of x upon mod x into the differentiation of x square minus 7. We know that the differentiation of 7 is 0 and the differentiation of x square is 2x. So finally we would have 2x into x square minus 7 upon mod of x square minus 7. And in the answer you can see that it is written that x cannot be root 7 plus or minus root 7 because we cannot have the denominator as 0, which is why you must also write that x is not equal to plus or minus root 7. Moving on to the final question for today, we have y is u minus 1 upon u plus 1, where u is root x. So again, they've simplified it for us because the original question would be root x minus 1 upon root x plus 1. They've already kept that as one term. Using the differentiation of u by v rule, we have v into the differentiation of u minus u into the differentiation of v upon v square. So here we have dy by dx equal to u plus 1 into the differentiation of u minus 1 minus u minus 1 into the differentiation of u plus 1 upon u plus 1 the whole square. So u plus 1 stays as it is. The differentiation of, so let's just take u as root x. I just feel like it will be simpler that way now that we have the expanded form of the differentiation. So let's keep this as root x plus 1 into the differentiation of root x minus 1. Differentiation of root x, this is du by dx. That's what we would write anyway, right? So we would write du by dx minus d of 1 by dx. So anyway, we're just simplifying it. We're reducing the number of steps by taking du by dx as 1 upon 2 root x. 1 upon 2 root x, differentiation of 1 is 0, minus root x minus 1 into du by dx plus d of 1 by dx, 1 is 0, differentiation of 1 is 0, and du by dx is 1 upon 2 root x minus root x plus 1 the whole square. So here we have a common denominator now. We have root x plus 1 minus root x minus 1 upon 2 root x. Let's just take the denominator as 1, root x plus 1 the whole square. I just took this denominator down because we already have a common denominator. So root x gets cancelled and 1 gets cancelled. Sorry, because there is minus. So minus root x plus 1. So 2 upon 2 root x plus 1 the whole square. 2 gets cancelled. The final answer would be 1 upon root x plus 1 the whole square. So that's it for today, guys. Thank you so much for watching. I'll see you in the next video. Bye.